So this lesson is on piecewise functions, and you all really haven't learned about piecewise functions, I don't think, since you were in Algebra 1. So it's been a little while. But the first question is an algebra question. So what are some factors that play a role in choosing a cell phone provider and picking a plan? Yeah, that's the big one. When you live in a small town like we do, another thing that's important is reception in your area. Did anybody think of anything else? Okay, those are the two main things you have to think about. Okay, Metro by T-Mobile offers an unlimited text and talk option with 2 gigabytes of data per month for $30. If you exceed that, then you pay $10 per gigabyte for each additional gigabyte. So if someone only used 1.7, how much would they pay? Yes, ma'am. What about 3.5? Yes. So you pay $30 for the first 2 gigabytes. And then $10 for how many more? Yes. So what did you do mathematically to get that 1.5? Subtract. So you did 3.5 minus 2. That's going to come into play in just a second. All right. So then we're supposed to do the graph. So between 0 and 2 gigabytes, how much are you going to pay? Yes. So there's a horizontal line between 0 and 2 gigabytes. And then after that, it's going to be $10 more for each gigabyte. So that just goes up by 10 for each gigabyte, and then you would connect them. That's the graph. All right, and then for number 4, we're going to write a rule that gives the monthly cost. This is what, the one part I wasn't sure if you would just remember it from Algebra 1. So we're going to call it C for cost, I guess. We can call it whatever you wanted to. And this is what's called a piecewise function. There's 2 separate pieces. And so we write a rule for the first piece where it's always 30. And that's when x is between 0 and 2. So you pay $30 even if you don't use your phone, I guess. All right, and then after that, we have a new rule that you still pay the $30, but then you pay $10 for each additional minute. So $30 plus 10. We don't just multiply the 10 by x because then you're paying double. You've already paid for the first 2 minutes. Oh my goodness. So we go back to this right here. This is the same as the amount that you use minus the 2 gigabytes you already paid for. And that is 4 gigabytes that are more, not equal to, just more than 2. If it equals 2, you just pay the 30. All right. That's a piecewise function. So on the rest of the notes, we are going to do 3 things with piecewise functions. We're going to evaluate them, which is probably the easiest out of the 3. We're also going to graph them. Can be a little challenging. We did a graph, but it can be a little challenging. And we're going to write a piecewise functions, which is the most challenging by far. All right, so piecewise defined functions have different rules for different intervals of the domain. So we'll have multiple pieces to tell you what to do for different parts of the domain. All right, so to evaluate, you're going to determine which interval your input belongs to. And then you're going to substitute the input into that piece only. We're not going to, when we evaluate, we're not going to put a number into multiple pieces. You just pick one. Okay. So we have this Pizza Palace problem. So Pizza Palace is offering a promotion. The cost of a large pizza in dollars as a function of time. This really threw my last class for a loop, but time is measured in days since February 10th. And it can be described by this function. And so number 1 says that we want to know the price of a pizza on Valentine's Day. So if T is the number of days since February 10th, what would T be for February 14th? How many days? Yeah, you guys see that, right? Okay, some people don't. So 14 is 14 is 4 days since the 10th. I don't know why people didn't understand that last class, but like nobody understood that. Oh, well, I told you right here. Your girlfriend would appreciate it if you knew when Valentine's Day was. All right, she'll remind you. All right, so we are going to put 4 in for T, but we're only going to put it into one piece. So when we're deciding what piece, we look over here. Which one of those intervals does 4 fall in? The middle one, right? Yeah. 4 is between 3 and 8. So that is the only piece we're going to use for this part. It would be 7 plus 4. That would be an $11 pizza. It's a pretty cheap date for Valentine's Day. It's definitely okay. All right. Number 2 says, on what days should you go to the Pizza Palace to get the best deal, and how do you know? So what is the cheapest pizza here? Yeah, the top one, $7 pizza. What days, starting with T is the number of days since February 10th. What days would you get the cheapest pizza? 10th through? Yes. So it goes up once you get to the Valentine's Day. All right, and then number 3, ask us to find C of 9 and C of 8 and then subtract those. So first we're going to plug 9 in for T just for one piece. Which piece? Bottom piece, right? Is that what you said? I can't hear. I got so many sounds going on. I got coughing, I got fans. So we're going to put it in the bottom piece. And everything I put in the bottom piece is just $18. Why is it the bottom? Yeah. Because 9 falls in between 8 and 28. Oh, that's good. All right. Now 8 is a tricky one because there are 2 8s. We are only going to put it into one. How do you decide which one to use for 8? What? Well, you're going to pick the one that has the or equal to bar. So if it equals 8, 8's the number, you use that one. So we're going to use the middle piece. Did y'all hear that about the or? Okay. Oh, good. So it's going to be 7 plus 8, so that's going to be a $15 pizza. All right, so the question is to find C of 9 minus C of 8. So we subtract 18 and 15, that's a $3 difference. And then they also want you to interpret that in the context of the problem. So it costs $3 more for pizza on February, what do you think for 9? 19, thank you. And then 18. So that extra day costs you $3. And then for number 4, what is the significance of the domain restriction? So this function is only 4 t-values from 0 to 28. So after 28 days, the sale is over. All right, and then for number 5, we're going to do the graph. Now, one thing that didn't come up when we did the cell phone problem is that sometimes you're going to have open circles, open endpoints, and sometimes you're going to have closed. So the things that determine that are these or equal to bars, or if there is not an or equal to bar. So for this first piece, they both have or equal to bars. So do you think it's going to be open or closed circles? Yes, ma'am. All right, so I'm going to draw that little section. It's going to be a horizontal line at 7 with closed endpoints when t is between 0 and 3. So like that. All right, so the horizontal lines are pretty simple to do. The slanted lines and the parabolas are a little more complicated. So let's look at that next piece. It is going to be a slanted line. So what I'm going to do for it, I'm going to do a little table of values. Alright, and this is going to throw you off and you're not going to want to do it, but just trust me. Anything that is for that piece, if any number that's on this interval, the endpoints of the interval are going to get plugged in to that point, or to that piece. Even though the 3 doesn't have an or equal to bar, just trust me, it's okay. Alright, so when I plug 3 in and I add it to 7, what am I going to get? 10. And what if we already did 8 and we got 15? Alright, this 3, do you all think it's going to be an open or a closed circle? It's going to be open. So it's going to be fine that we plugged it in. 8 is going to be closed. Alright, so at the point 310, we're going to have an open circle. And then at the point 815, we're going to have a closed. And then those are going to be the endpoints of your little line segments. And that's it. All right, and then the last piece is we just have $18 pizza for a long time. $18 pizza between 8 and 28. Because 8 doesn't have the or equal to, it's going to be open. 28 does, it's going to be closed. Alright, so we're just going to have this horizontal line with open, closed. There it is. Alright. Any questions so far? Piecewise functions are very time consuming to graph. Alright, so the next one we're not going to graph, we're just going to evaluate it. So I'm going to start with f of negative 10. Which piece So looking at these, which piece would I plug negative 10 into? The first one, yes. And the reason is negative 10 is less than negative 6. It's on the left side of negative 6. All right, so f of negative 10 means we're going to have the absolute value of negative 10 minus 3 plus 1. Now your calculator does have absolute value, but I'm just going to try and do as much as we can without a calculator. You don't have to be super dependent on it. So what is negative 10 minus 3? So it's like you owe someone $10 and then you borrow borrow $3 more from them. Yeah, now you owe them $13. But this absolute value is magical because it just drops off at negative because it's the distance away. And so that's going to be 14 when we evaluate it there. What's wrong? Okay. All right, so for the next one, we're going to evaluate f of negative 2. So look at your intervals and decide which piece we're going to use for negative 2. Yep. Because negative 2 falls in between negative 6 and 2. All right, everything I put into the middle piece, I'm going to square and then subtract 10 from it. So what do you get when you square negative 2? It's just 4. And then 4 minus 10 is negative 6. All right, what do you guys think about 2? It's a tricky one. Which piece are we going to use for 2? The middle again. So 2 is in 2 places, so we have to use the one that has the or equal to. There'll only be one that has an or equal to. So it's like we get negative 6 again. All right, you guys try the last one on your own, f of 5. Decide what piece and then plug it in. So because 5 is greater than 2, we are going to use the bottom one, and then it's pretty simple. Just multiply by 2 and subtract 5. All right, any questions? Okay, let's do a graph. It's not going to be super simple. But it would be helpful if you guys knew what these little sections were going to look like. So 2 of these sections are going to be little line segments, and one section is going to be like part of a parabola. So which 2 do you guys think are line segments? That would be linear functions, but only part of the line. Top and yeah. So anytime that the x has a square on it, it's going to be a parabola. Or if the square is the largest power. All right, so 2 line segments and 1 parabola section. And none of these are horizontal lines. So the thing I did at the beginning when wait, hold on, where did I do it? Pizza place. Where I did this little table, we're gonna do that for every piece. So it's gonna be a little bit more time consuming. All right, so let's just start with the first piece. A little line segment. This is different. I mean, there's only certain numbers I can put in here, and they have to do with this. And so to get a good graph, you put in these numbers, the ones at the ends of your segment. So we're going to put in -7 and we're going to put in -3 to that first piece. When I put in -7, is that going to be an open or a closed circle? For -7, it's going to be closed. What about -3? Nice, nice. All right, now when you do this on your own, you can use a calculator. I'm trying to make sure we get finished. So I'm going to put in -7, multiply it by -2, which is 14, subtract 8 from 14, and that's going to be 6. All right, then I'm going to put in -3, multiply it by -2, which is 6, subtract 8, which is -2. All right, so for this little piece, we're going to go to -7, 6, and it's going to be a closed circle. And then we're going to go -3, 2, -2, and it's going to be open. And then we're going to connect those pieces. That's our little line segment. All right, then we're going to have a little parabola section. It's going to be a little tougher. But you guys can do it. I'm not worried. All right, what two numbers am I going to put into this table? Yes, ma'am. Leave a little space between them, just a little note. Okay, -3 going to be open or closed? Good. And 2? Nice. All right, these numbers, when I put them in, I'm going to square it. So that's going to be 9. And then make it negative. It's going to be -9. And then add 4 to it, which will be -5. 2, I'm going to square it, which is 4, make it negative, add 4 to it, that'll be 0. So if I do -3, -5, and 2, 0, does that look like a parabola? No. So let's just put in something else that falls in between those. So what's the easiest number to put into a function? What's the easiest number to plug in? 0 is usually the easiest number because if you put in 0, anything that has an x just disappears and you're just left with the other number. So if I put in 0, I'm going to get 4, which will be here. And now with 3 points, I can get a little U-shaped graph, a little parabola. Oh, it's a little wobbly. So we couldn't do a line segment on that one, so I needed a third piece because I knew as it was x squared, it would be a U shape. But this last piece, I know is going to be another little line segment, so it's not going to be quite as challenging. Y'all want to try it on your own? Why don't you try it? So in this piece, everything you plug in, you're going to take half of it and then subtract 4. All right, does your piece look like mine? Yay, good job. All right, we're almost done. One more. This is, I think, the most challenging is getting the equation, but I could be wrong. It might be doing the graph. I don't know. Okay, so this is the piecewise function, and we're going to write the equation for it. It is called f of x. How many pieces is it going to have? 3 pieces. 2 slanted lines and line segments and 1 horizontal line segment. Okay, do you guys remember slope-intercept form from Algebra 1? I'm just about messed it up. Y equals mx plus b. Okay, so m is the slope and b is the y-intercept. So that's what we're going to use to find these equations. So the first piece, we're trying to figure out the slope. And so to move along, looks like we're going down 3, right 1, down 3, right 1. That's the slope of -3. But we can't see where it crosses the y-axis, so we can't see the y-intercept. So I'm just going to continue the graph. So we're just going to try and figure out like where it's going to cross, if it did cross the y-axis, where it would be. Alright, so if I go from here, I go down 3, right 1, down 3, right 1. Looks like it's going to cross at -10. Okay, so that's part of it. The other part is figuring out those intervals. So for that first little section, what is the smallest number in that interval? Smallest x number in that interval? -5. And I do less than. Do I need to do a less than or equal to for -5? Yes. And then what's the biggest one in that little section? Biggest x? Do I need a or equal to? No. Nice. All right, let's do the middle piece. We need to look at our slope. What do you guys think for the slope? Up 1, right 2. So a slope of 1/2. Now this is great because you can see where it crosses the y-axis. What's the y-intercept? Yeah, so +2. Okay, and then I'll do my little interval. So this x starts at -2. I do need a or equal to. And then it goes to 2. And I don't need a or equal to. All right, and then the horizontal lines are my favorite. So what is the graph always going to equal right here? Always going to be 4. It's never going to be anything else, so that's easy. And between what 2 x values? Good. Do either one of those need or equal to bars? Good job, guys.